All right, let's look at a variety of problems involving percent and see how to approach them. At a certain school, 236 students have cell phones. If this is 42% of the school's population, how many students go to the school? So our job with a percentage problem is always to sort out what is our part, what is our total or base amount, and what is our percentage. And your part and your percentage always go together, meaning that if you have a 42%, which represents the percent of the population with cell phones, then your part would have to be the number of people with the cell phone. And is that what our 236 is? Is our 236 the part of the population with a cell phone, or is it the total population? And in reading the question, you can tell that that is the part. So what is unknown is our total. So we can set up our equation using part divided by total equals percent divided by 100 for those people that like to use the proportion approach. Our part is 236, our total is unknown, and that connects with the 42% being the percent with cell phones over the 100. Or, if you prefer to use the formula percent as a decimal multiplied by total equals part, then your percent 0.42 multiplied by our total, which is unknown, would equal 236. Either way, you're going to come up with the same answer. So here we'll cross multiply and divide by 42. Here, 0.42 times x equals 236 means that to get x, we must take 236 and divide by 0.42, which if you do that, will give you approximately, so I'll put an equals with a dot over top, approximately 562 students in total go to the school. Another example, the number of people at the country fair this year increased 56% over last year. If the previous year's attendance was 500, how many people attended the fair this year? All right, so again, we have to sort out what's our part, what's our total or base amount, and what's our percentage. And the extra complication in this question is that the question says increased 56% over last year, which means that our increase percentage is 56%. Or if we would rather look at it as the percentage of the original amount, that would be 156% of the original. There's kind of two ways I can work with this. Do I want to work with the 56% or do I want to work with the 156%? Either way, we're going to get the same answer. I'm going to work with 156%. 156% means that our part would have to be the number of people that the 156% represents. Well, the 5,000 is our original amount. It's our base amount, so that's our total. So the 156% will be the part. So if I set up part divided by total equals percentage divided by 100, my equation will look as follows. X over 5,000 equals 156 over 100. If you would prefer to set up your equation as the percentage of the total equals the part, then you would set this up as 1.56, your percentage in decimal form, of, which means multiply, your total, which is 5,000, and that will give you the part, which in this case is more than the original. This multiplied by this will give you the part. That will result in the same answer as cross-multiplying and dividing by 100. So if you take 1.56 and multiply by 5,000, you will get 7,800 people. So 7,800 people attended the fair this year. Our next example, we have a small town whose population is growing, and we want to know the percentage increase. Because we want to know the percentage increase, we will need to know the amount of the increase, because the percentage and the amount always go together. So we don't know the percentage increase. The amount increase would be the difference between the populations, the new population and the original population. And if you calculate that out, you get 2,037 people. Okay. Our total or base amount in these kind of questions is always our original population, which is 3,856. So therefore, we can use part divided by total equals percent over 100 to get our missing quantity. Our part, our amount of increase, is 2,037 compared with an original population of 3,856. And what we're calculating is x divided by 100. That's how you would set the problem up with cross multiplication. If you wanted to set it up using the formula percent as a decimal multiplied by total equals part, then you would take those numbers, and this would be your unknown, x, multiplied by your total, 3,856, which would equal your part, 2,037. And since we've got x multiplied by something to get this, that means that x would be calculated by taking 2,037 divided by 3,856. If we type this into the calculator, or if we do cross multiplication, we're going to get the same answer. Let's finish the problem off this way this time. If we do 2,037 divided by 3,856, we're going to get 0.52826 ... which is our percentage as a decimal, remember. Therefore, the percentage increase is 52.83, because it asks for 2 decimals, percent increase in population. Another question. For every item that a salesperson sells, he earns a 4.5% commission. Selling on commission is a way that many salespeople earn their living, where they get a percentage of the price of the item they sell as their take-home pay. So for example, if our salesperson here sold a $100 item, he would earn 4.5% of that $100 item, which would be $4.50 in take-home pay. So the more he sells, the more he makes. So we're told here in one day Sal sells $6,000 in merchandise. So what is his commission for the day? So this time let's use the formula percentage as a decimal multiplied by total equals part, or I could set this up as a proportion if you prefer. We have our percentage, which is 0.045. This is the percentage of commission, so over here we will get the amount of commission, which is what we're being asked for. Our total is the amount that he's selling, which is $6,000. So we multiply those two amounts, and we come up with $270 in commission. An example involving sale price. An iPod is on sale for $159.99. If the item was discounted by 18%, what was the original price of the item? So the original price is our base amount or our total. This is what we don't know. What we do know is the amount paid for the cell phone, $159.99. This is going to be our part. This is the part that we paid for. And so since we have the amount that we paid for, what we're going to need to know is the percent that we paid. Well, what we know here is the percent of discount. This is the percent we did not pay. We did not pay 18%, which means that the percent we did pay would have to be 100% minus 18%. In other words, we paid 82%. Remember, I'm calculating this because these two things go together. The percentage of what you know is going to be the amount of what you know or need. So when we go to set up, let's do a proportion this time. Part divided by total equals percent divided by 100. That would mean that the part that we paid, $159.99, out of our unknown total we don't know, will relate to 82 out of 100. So we'll cross multiply. We'll get 82x equals 15999. We'll divide by 82. And that will give us $195.11. So the original price of the iPod was $195.11. Now, if you're questioning whether that's correct, let's check our work this way. Let's take our final price, which would be the total we've paid, and let's take 18% of that. 18% of the total would be the part we don't pay. We don't pay $35.12. So if we then took that amount off of the price we've calculated, $35.12, do we get $159.99? Yes, we do. So we know our answer is correct. And one final question. We have an item that's reduced in price by 20%, and then after a week the item is reduced in price by another 15%. What is the total percent reduction in price from the original? So when you look at this question, you see we go down by 20%, and then later we go down by 15%. And I guess the question would be, does that mean that our final item has been reduced by 35%? Can we just add the two percentages to get the percent reduction if we have two separate price reductions? So let's work this out and see if that is the case or isn't the case. All right, we don't have an original price to go with here, which means we can make up anything we want. So let's start with an item, and let's make this easy. Let's suppose we have a $100 item. If it's 20% off, that means we would pay 80% for it, which means the $100 item would become $80 after 1 week. Okay. Now we're going to take that $80 and we're going to take 15% off of the $80. So if we take 15% of the $80, that is going to be $12 off. In other words, the item will now be priced at $80 minus $12, which is $68. Remember, of course, we could have done this calculation instead of doing 15% of 80 and then taking that amount off of the 80. We could have simply done 85% of 80 to get 68. So what we can see now is that our item has gone from $100 down to $68. In other words, our item is $68 compared with the original 100. It's now 68% of the original price. And if it's 68% of the original price, that means that the percentage discount, the percentage reduction, is 100% minus 68%, or 32% reduction. And you'll notice that is not the 35% we had thought perhaps it could be. So when you have multiple percentages being applied to an original amount, you can't just add or subtract the percentages to get the final reduction. You have to do the calculation separately for each part and figure out what that final amount is.